In this video, we are going to know a little about quantum mechanics because this is kind of an interesting topic, and you might have listened this word ever before because it's kind of a popular word. So without wasting time, I'm going to start this video. Actually, quantum mechanics is the field of physics that explains that how small objects have characteristics of both particle as well as wave nature. In short, particles are the tiny pieces of matter, and waves are a disturbance or a variation that transfers energy. This is all this the wave-particle duality. The particle nature of the wave-particle duality involves how small objects can be described as quanta. Actually, a quanta is a smallest discrete unit, such as a particle of a natural phenomenon in a system where the units are in a bound state. For example, a quanta of a light is photon, and as I told of bound state just before 5 seconds, it is where the particles are trapped. For example, electrons, protons, and neutrons in an atom. To be quantized means the particles are in a bound state and can only have discrete values for properties such as energy or momentum. So for example, an electron in an atom can have very specific energy levels. This is different from the macroscopic world where the particles can be of any value in a range. A baseball can have essentially any energy as its form travels through the air and then gradually slows down. At the same time, tiny quantized particles can also be described as waves. Waves in the quantum world are constantly shifting. In quantum mechanics, scientists talk about the particle's wave function. As quantum mechanics grew out of the tremendous progress that physicists made in the early 20th century towards understanding the macroscopic world and how it is different from the microscopic world. As with many things in science, new discoveries prompted new questions. Prior to this time, scientists thought that light existed as an electromagnetic wave, and that electron existed as a discrete point-like particles. However, this created problems in explaining many phenomena in physics, like black body radiation, which means the emission of lights from objects based on their temperatures. Quantum mechanics also helped explain the structure of the atom. It helped make sense of photoelectric effect that involves the emission of electrons from materials when a light of certain wavelength hits the material. By explaining how these can be both particles and waves, quantum mechanics solve the problems. So this new knowledge has performed many effects in science and tech. Quantum mechanics led to the development of LEDs, lasers, electron microscope, medical imaging, and a host of other modern devices. Smartphones contain billions of transistors that work based on the wave nature of electrons that scientists understood from the quantum mechanics. Quantum computers and quantum networks are new features of quantum mechanics that use to quantize nature of particles to store and transfer information. I hope you got to know something interesting, something new.